All right, this is the second part of 7-5. I did want to just go back and just talk about this graph really quickly because this graph is a very important graph. This is basically a sine function. So the graph that you see is the graph of sine. And how you know this is the graph of sine is if you were to think about, let's go back to our unit circle and our values. So this would be 0, this is pi over 2, pi, 3 pi over 2. And if we look at just the points that are on our unit circle, so -1, 0, and then 0, -1, if you remember, sine is always going to be the y. So sine of 0 is 0, and if I look to my graph here, sine of 0 is 0, so it hits at the origin. Sine of pi over 2 has a value of 1, so sine of pi over 2 has a value of 1. And I can continue, sine of pi is going to be 0, so sine of pi hits at 0 on the x. And then sine of 3 pi over 2 is -1, which is what I got there. So this curve starting at the origin at 0, 0, and then going up 1 and having a period of 2 pi is the sine curve. Just really quickly, I wanted to sketch out the cosine curve so you can just kind of see the difference. So the cosine function, and again, remember cosine is just the x's of these values. So I'm going to just plot, and it's just going to be a really quick sketch so you can see. So this time when we're at 0, cosine has a value of 1. So we're at 0, we're going to go up to 1 and put a dot. And then at pi over 2, we have a value of 0, so it's going to be here. At pi, it has a value of -1, so that's down here. And then at 3 pi over 2, it has a value of 0, so we're back up. And then again, it starts back over again. So this graph here, let me get a piece of it sketched for you. Sorry, it's much better when you do it on the, and it'll continue this way as well. This piece here is actually going to be what cosine graph would look like. Sorry, I'm trying to really darken it up so you can see it. So in purple is what a cosine function would look like. So they're very, very similar. We're not going to do a whole lot with them. You'll do a lot more when you go to pre-calc next year. But just so you could kind of see a sine function versus a cosine function. So again, they look very similar on how the waves go. Okay, so then our next two examples that we were going to continue on. So again, finding the three basic things of a periodic function. So period, midline, and amplitude. So again, period is the overall distance. And again, you're more than welcome to measure top to top. So here's a top and here's a top. So if I were to measure that distance, I can also do min to min. Looks like here to here. So now you're noticing that the numbers are not super awesome. Okay, you're hitting halfway between parts. So don't forget that the other option is just to find out when the graph is repeating. So if I were to start here, it's always best to start on the y. It's halfway, so I'm going to try to figure out when it repeats. So it looks like it's going to repeat starting here. So this would be one period of the graph. So from 0 to 4 is where one period would lie. So the period is going to have a distance of 4. The other way to do it mathematically, again, is just to look at your tops and your bottoms. So this one is hitting at 2.5, which is 5 over 2. And then this one is hitting at -1.5 or -3 over 2. If I do 5 over 2 minus a -3 over 2, that gives me 8 over 2, which is 4, and it still matches. So you can do it mathematically, or you can just try to find the distance based on looking at the graph, which I find is a little bit easier. Now we're going to go ahead and find the middle. So the middle of the graph, so your min is here and your height is here. So it looks like this line right here will be the middle. And again, just double check it. Your height here and your min here should be the same value, and they are. It's up a half and down a half. So this line here, which is 1.5 on the y, so y equals 3/2 or 1.5, is going to be your middle. Again, it cuts it into 2 equal pieces, so the top and the bottom have to match. And then the amplitude, the overall height, we already talked about, but let's just go back over that. So this distance here, this distance, if I look, is a half, 0.5. And then if I do the same thing here, this distance is also a half. So our amplitude is 0.5 or a half. All right, last one. So for this one, finding the period, this one's not so bad. It hits right on, which is nice. So from here to here, so I'm at 0, and then I go to 3. So the period is going to be 3. Again, don't forget your mins have to match as well. So from here to here has to be the same difference. These are fractions, so just when you add them over, you can either just count. So that's a half, and then 1 and 2 and another half, which is still going to give you a 3. So you don't always have to put a formula to everything. You can just count the spaces. Our middle line here, let's see. Let's find the total height difference. So from here to here, so that's 1, 2, 3, 4, 5, 6, 7, 8. So we're 8 total. So if you divide that by 2, that's 4. So you know your midline is going to be a distance of 4, but let's find the line. 1, 2, 3, 4. So it looks like here is going to be our middle. Okay. And again, I just found the top and the bottom and cut it in half. So our midline is going to be y equals 2. So it's a distance of 4, but you need to make sure the distance going up and the distance going down match. And then our amplitude is exactly that. It's this distance here, which I have 1, 2, 3, 4. And just double check that it matches here. 1, 2, 3, 4, and it does. It has to match. So our amplitude is 4. So you're going to do that same setup when you work on the homework. And good luck.